So this is gonna be the last talk for this day. So this is Dustin Whittle. So he initially started his career as an architect at Yahoo, and then he was a consultant trainee for performance. And then he worked as a developer eventualist at AppDynamics. And today he's here to give a talk on performance testing for modern apps. So over to him. Shall we have a big applause for him?
All right. So thanks for having me. I come from San Francisco, so it's quite an honor to be here and visit. We're going to be talking about performance testing for modern apps today. The reality is that top engineering organizations don't think of performance as a nice to have, but really as a crucial feature. And unfortunately, most engineering teams don't regularly test for performance. So in this talk, we're going to be talking about how you can test performance and do capacity planning on the server side, and also understand performance on the client side. So again, my name's Dustin Whittle. You can find out a bit about me at dustinwhittle.com or follow me on Twitter. I'm going to talk a little bit fast because there's a lot of slides to cover. So first, why does performance matter? The reality is if you look at some of the top engineering organizations in the world, they really do treat performance as a feature because they understand that it directly impacts their business's bottom line. So if you take a look at Amazon, Amazon.com's e-commerce retail operation, for every 100 milliseconds that they shave off the end user experience, they increase their revenue by $1 million. So the reality is that it's quite significant. With Yahoo, for every 400 milliseconds they shaved off serving an ad result, they increased their conversion ratios. And then for Mozilla, shaving 2.2 seconds off the landing page experience for Firefox downloads increased the downloads by 60 million. So the reality is that performance directly impacts the business's bottom line. So you should invest in performance, and you should treat it like a feature, and you should test it like you would anything else. But first, how does the brain perceive performance? 0.1 seconds or 100 milliseconds, it feels instantaneous. It feels like you're flipping a page in a book. You don't lose the context. You're able to keep your train of thought. After 1 second, you can still start to think seamlessly, but you can start to notice the delay. The delay becomes perceptible. And after 10 seconds, it's proven that users will abandon your site. I think anyone who's gone through a slow e-commerce checkout can relate to this experience. When you add everything to your cart, and then you click the checkout button, and then it just waits, and you start to lose faith. The engineer in all of us knows to just wait it out so you don't get charged again. So again, how fast is fast enough? Performance is really key to a great user experience. Under 100 milliseconds is perceived as instantaneous. 100 milliseconds to 300 milliseconds, the delay becomes perceptible. And the user's expectancy is for a page to load in under 3 seconds. After that, 40% will abandon your site. But the reality is in modern applications, you spend less time on the server side than you do on the client side. So it's not just enough to understand the server side performance and the scalability of your servers and your infrastructure, but really how does it actually interact in your real users' browsers. So again, treat performance as a feature. And in this talk, we'll be going over some tools of the trade for performance testing so that you can do just that. So first, I like to start with understanding your baseline performance. Every piece of the application stack adds overhead, so I like to start at the bare metal and then work your way up. So in a Python application, you're probably serving Nginx or Apache, serving static assets. Then you probably use a framework like maybe Django or Flask. You do a hello world to figure out the overhead of that specific framework, and then you have the overhead of your actual application logic. So I like to do a load test for each different scenario so I understand what's the maximum request per second and the average latency for each stack of the application. So we're going to start very simple, and we'll get progressively more advanced. So the simplest load test that you can run is using Apache Bench. If you've installed Apache, you have access to the Apache Bench command line, and this makes it extremely easy to load test simple applications. So when I say a simple application, I mean a single endpoint. I don't need to go through a complex user flow. I just want to understand if I go to the home page, how many concurrent users can go to the home page at a single time. So for this, we'll install Apache Bench, and then you have access to the AB command. So in this case, we just want to run Apache Bench with a concurrency of 1 user for a time of 10 seconds. So I want to have 1 concurrent user for 10 total seconds and get an understanding of the baseline of performance. So this is what it looks like. I have a pretty poor performing application, so you can see that I get 18 requests a second with a single user, and I have a time per request of 53 milliseconds. Now, you don't really run a load test with a single user, so let's increase the concurrency and start to see how the application behaves. For this, you can just increase the -C for concurrency, so Apache Bench -C for 10 for a time of 10 seconds, and -K means benchmark mode. So I don't want to have a delay between the requests. I want to spin up as many concurrent users as possible. And then you can start to see how the application performs over time. So here the time per request has gone up. Now it's 151 milliseconds, but the request per second has also gone up to 65 milliseconds. So Apache Bench is extremely easy if you just want to get a baseline for your server. If you're just running Apache or Nginx, it's a very easy way to load test your application. But I prefer Siege. Siege is very similar. You can apt-get install Siege or port install Siege depending on your preference, and it has a very similar convention. You can run Siege, -C for concurrency, 10 concurrent users, -B for benchmark mode, so no delay between the request, and then I want to run the load test for 10 seconds. And then you'll get a very similar output. This time I get 65 transactions a second, and an average response time I think of 50 milliseconds. Okay, so when you have a single user and you have a single endpoint, it's very easy to run a load test, but what happens when you want to generate massive amounts of concurrency? What about when you need more than one machine? So by a show of hands, how many of you manage a production application that has more than one server? Right, anyone who manages real applications understands that you need to be able to create massive amounts of concurrency to really stress test your infrastructure. So I like to talk about this one because it has this amazing title. We're gonna be talking about bees with machine guns. I mean, look at that logo, come on. All right, so what is bees with machine guns? It's a utility for arming mini bees to attack targets, where that means using Amazon Web Services public cloud to spin up EC2 instances or cloud compute instances to load test your applications. This allows you to run distributed load tests effectively. So it's pretty easy to install. Pip install bees with machine guns. And then you configure some EC2 credentials. So if you're not familiar with Amazon Web Services, you can get started at aws.amazon.com/free for 3 months, or for a year rather. And all you really need is a key and secret, and then you can start to spin up instances. So all you do is define the key and secret in the boto config file, and then you can use the bees command line. So in this case, I just want to run 2 servers, but this could easily be 10 or 200, depending on the level of concurrency that I want to generate. So here we'll call bees up -S2. So -S servers, the number of instances I want to turn on, 2. And then the rest you could pretty much ignore, but the idea is that I want to be in the default security group in the US West 2B data center, or availability zone, and I want to use this SSH key and user to log in. Once you've done that, it'll generate this output. It's going to connect to the hive, attempt to call up 2 bees, it's going to wait for the bees to load their machine guns, and then when the bees are ready for attack, the swarm has assembled 2 bees. All right. So then you can call bees attack. So the idea here is I want to spin up EC2 instances, so I want to turn on multiple servers, and then I want to orchestrate a load test or a distributed load test. So you can call bees attack -n, the total number of requests that you want to generate, and -c, the level of concurrency. So I'm just generating 50 concurrent requests, but this is quite low. I can generate this from my MacBook and a slow Wi-Fi connection. But what happens when I want to generate 50,000 or 100,000 concurrent requests? So here we can slowly increase the level of concurrency, and then we can call bees attack, and we'll get this output. So here with 50 concurrent users, testing 1,000 requests total, each of the 2 bees will fire 50 rounds, 25 at a time. And more importantly, it's going to sting the URL. So it's going to pre-cache. It's going to make a single request to prime the cache for your application, and it's going to discard the results of that. And then it's going to generate the load test. So it's going to organize the swarm, it's going to run to a mission, and then the offensive is going to be complete. And the mission assessment, the target crushed the bee offensive, which means your server survived. And then you can see the performance benchmarks. Behind me, you'll see the request per second is now 306 requests per second at 50 concurrent users. And the time per request is 163 milliseconds. So again, when you want to run load testing, you really want to see how scalable is your infrastructure, and at what point do you max out the level of concurrency. You can always get increased concurrency at the expense of additional latency. So what you really want to understand is what's your performance budget? What's the optimal time for your application to respond? So if you want to keep all of your requests on the server side responding in under 100 milliseconds, how many servers do you need to be able to generate that? If you increase the level of concurrency, you can always get more requests out of the machine, but each request is going to take longer. So when you're doing load testing, part of it is you want to figure out what is optimal for your application and for your performance budget. So here we'll increase the level of concurrency. So we'll call bees attack -n. We're going to generate 100,000 requests, 1,000 concurrently for a simple demo. So again, the same thing. It's gonna, each of the 2 bees will fire 50,000 rounds, 500 at a time, and it's gonna pre-cache the URL. And then now you'll see that we are able to get 502 requests per second, but the average latency for each request has gone up to 360 milliseconds. So for each one of these, you can keep repeating the cycle until you hit your maximum level of concurrency, and you can start to understand how much your infrastructure can currently support. Now, running load tests is optimal for cloud environments where the costs scale linearly with demand. So usually when you run load tests, you need many servers for a very short amount of time, so you only want to pay for what you use. So with bees with machine guns and Amazon Web Services, it becomes very easy to spin up instances on demand and then tear them down when you're finished. So you can call bees up to turn the instances on, bees attack to load test your instance, and then bees down to turn off the instances. And here we're just going to shut down the 2 instances and get an output. So, okay, we covered Apache Bench, which is very simple load testing for a single endpoint. We covered Siege, which is my preferred tool for testing a single endpoint. And then now we've talked about bees with machine guns, which allows you to run a distributed load test in a cloud environment. But what happens when you want to test more complex user flows? People don't just go to the home page and refresh the home page a bunch of times. People go to the home page, they create a user account, they add something to their cart, they check out, they go and check the status of an order. Each one of these transactions has different performance characteristics, and when you talk about performance testing, you really want to understand what does the entire application performance look like, and what are your slowest endpoints. And more importantly, you want to instrument your infrastructure so that when you generate massive amounts of concurrency and you stress test, you can understand what breaks and why. The whole goal of performance testing is 1, to understand what's the maximum performance your infrastructure can handle, but 2, what breaks when things start to fail. So we'll talk about locustios, which allows you to script complex user flows and run distributed load tests at the same time. So you can emulate a complex user interaction, like going to the home page, creating a user account, adding something to your cart, and then checking out. So locustios is the website. It's available on GitHub, but it's easy to install with pip install locustios. So this is pretty straightforward Python code. Once you pip install locustios, you can create a set of website tasks or task sets. And the idea here is that you just describe your user behaviors. So in this case, I'm taking these examples straight off the website, so they're easy to follow later. But in this case, we want the user to go to the home page, and then on start, we want to log in the user. And then the first task we want to see is go to the profile, and then the second task is we want to go to the home page. But this could be as complex as you want for your application. But one of the better parts of locustios is that it gives you a web interface that makes it very easy to manage and spin up multiple instances. Even more so, you can run massive amounts of concurrency because you can distribute the load generation across multiple machines. And then you can aggregate the results. So once you've pip installed locustios, you can create a locust file. Looks very simple. And then you're able to get started. So run locust -f, or just if you run locust and name the file locustfile.py, it will be available. And then it'll run a web application that you can log into and start running massive amounts of concurrency. In this case, I just want to emulate 100 users, and I want to request them at 10 requests per second. So I want to slowly ramp up the traffic until I hit 100 concurrent users. And it'll give you a web dashboard that makes it easy to understand the performance results of each endpoint. In this case, I'm just using the home endpoint, but I could have many different, depending on the endpoints you define here. It'll list the result for each one. Check out locust.io for more information. But if you really want to get complex and you want to use a cloud environment to do distributed load testing, Google Cloud has written a great tutorial on how to do orchestrated distributed load tests using locust.io. So you can check it out on GitHub and follow the tutorial on Google Cloud. But the reality is that there are many tools to do load testing. Gatling, Work, Sung, there's a bunch of different tools. Pick whatever works for your flavor. The idea is that you should start doing performance testing as part of your software development lifecycle. In the same way you test functionality, you should test for performance as well. But that's just on the server side. The reality is that in modern web applications, more latency comes from the client side than does the server side. So it's not just enough to understand how the servers perform, but you also need to understand how it performs in a user's browser. This also introduces a bunch of different complications because users have many different environments. You have many different browsers, many different network connections, et cetera. So you need to be able to understand what performance looks like in each one of those. So the first tool we'll be talking about is the PageSpeed tools by Google. So if you go to developer.google.com/PageSpeed, you can get insights into what exactly is slow on the client side and how you can improve performance on the client side. So I know I'm talking to a room full of Python developers, but really you should be caring about the end-to-end performance, and these tools make it very easy to figure out exactly what's going on. So the Google PageSpeed tools make it very easy to test for performance on the client side, but more importantly, they have a bunch of different ways to do this. If you have Chrome installed and you go to the developer toolbar, you can very easily run a page audit, which will give you a performance assessment. If you don't have access to Chrome, you can go to their website and just type in the URL, and you'll get some actionable insights. So I should be minifying my JavaScript, minify CSS. I should move blocking JavaScript to the bottom of the page. I should use far futures expires headers so that I don't download the JavaScript and CSS every request. So some common best practices for front-end performance. But it's not always possible to adjust the code. Sometimes you own the application, but you can't actually make code changes. So in this case, they've actually released a PageSpeed module for Apache and Nginx that'll automatically rewrite the responses in real time so that you don't actually have to make any code changes, and you can immediately improve performance on the client side. All right. So PageSpeed Insights, check it out, developer.google.com. You can use it as a web service. You can use it as a Chrome developer tool, and then you can use it as the standalone website. But sometimes you want to be able to access this from the command line. So if you use Node, you can npm install PSI, or PageSpeed Insights, which will give you access to a command line that uses the PageSpeed web services. And the idea here is that you can get all the same advice via console so that you can integrate it with your continuous integration flow and start to treat these as functional test results. So the idea here is I can run PSI and then a domain, and the same response that I got from the website I would get in this form. So here I want to check the page speed score. In this case, it's a 73. I want to check the size of the CSS, the HTML, the JavaScript, and then I have some rules that I can improve. So I want to leverage browser caching. I want to optimize my images. And then if you're using a mobile form factor, you want to make sure you follow some mobile best practices, like making the tap targets big enough. Okay, so you can automate all of this stuff with Grunt or Gulp or whatever your tool, continuous integration tool is, or front-end build tool is. The goal here is that you should be doing this as the same way that you write a functional test or a unit test that need to pass every time you commit code. You should understand the performance impact of every change. By a show of hands, how many people understand exactly how fast their website is in production? All right, let's try this again. How many of you would call yourselves professional developers? There we go. All right, now how many of you find out about a problem because a user calls support, support eventually escalates it to operations, they eventually get it to you? Right, few people. Okay, and this is because you guys don't really do great monitoring in production. Your user shouldn't be your first line of defense. So again, when you're running load tests, whether it's on the server side or the client side, you should really be instrumenting these so that you actually yield useful insights from your load test. So you should instrument everything. Code, databases, caches, queues, third-party services, infrastructure, they all affect performance. There's no shortage of monitoring tools, so pick whatever flavor works for you. But before you start running load tests, you should track performance both in development and production. It's not something that you should just do at launch time or the day before launch, like most companies do it. You should do this as part of the software development lifecycle. So given the wide array of browsers, it's really hard to test all these different browsers across all these different connections and operating systems. So if you take a look at webpagetest.org, that makes it very easy to understand the performance of a specific browser over a specific network over a specific location. So if I want to test Opera in Sydney, Australia on Telstra's Wi-Fi 3G network, it becomes very easy to test this. But even more importantly, it allows you to get a visual representation of what exactly is slow and why. So here you get the same page speed score. You get the performance metrics of the first render. So without any cache, what does performance look like? And then a repeat visitor, what does performance look like? But more importantly, they also create a screenshot and some other tools that are useful for QA. So you can actually get a video of the rendering process. Now I have this really impressive website, dustinwhittle.com, which is just a list of links. And I steal this service from Google to give me all the favicons, and each one of those favicons results in like multiple redirects. So if you use webpagetest.org, what you'll see is I make a bunch of additional HTTP connections for no reason, just because all of these result in a redirect. So using webpagetest.org, you can test using any browser from any location over any network condition. So if you want to be able to start doing this very easily, they have an API so that you can automate all of this as well. But they also have SitesPIO. So I'm a big fan of SitesPIO because it'll test not just a single page, but your entire application or all the publicly discoverable URLs to understand what front-end performance looks like. So in an ideal world, I usually run locustios to test the server-side performance, and I run SitesPIO to test the front-end performance. And I integrate both to do it automatically with Gulp, and I'll get into that a bit. But the idea with SitesPIO is, again, it's a Node.js tool, so you can npm install SitesPIO. And then you can run SitesPIO-u and then a domain, and you end up with a dashboard that looks like this. And the nice thing is that you can generate this every time you run a commit or do a new build, and it'll tell you exactly what the performance changes between releases. And you can treat these as test artifacts and start to extract the values from them and then set up, allow a build to be promoted or not based on performance metrics. So you should create a performance budget. You should understand what's the ideal the ideal response time or latency for your users. And then you should use that to do capacity planning on the server side. But also you should understand as you iterate and create new features, how does each feature impact performance? It's not just the client-side performance, it's also the server-side performance. Did you upgrade MySQL? Did you switch from MySQL to Postgres? Did you introduce a new API like PayPal for web payments? All of these things can impact the overall performance, so it's good to be able to understand that. So the reason I like SitesPIO is it covers everything. It's not just the end user time, but it's how much time spent on the server side, the first byte time, the end user experience time, how many requests are cached or gzipped, et cetera, how many DNS lookups, how much time are you spending doing SSL negotiation, et cetera. Okay, going at a record pace. So the idea here is you want to be able to run load tests and you want to yield meaningful insights from this. You can use a wide variety of open source solutions. Pick whatever stack works for you. The goal isn't to sell our platform. The goal is for you to start using some level of production monitoring. And before you start to run load tests, you should really start to have the instrumentation in place. Because once you hit your maximum concurrency, you really want to understand what starts to fail and why. Do items queue up and never get resolved? Do you need more workers on the back end? Do they hang on the front end? What's the issue? A bunch of cache misses, a surge of requests to the database, et cetera. So there's a bunch of application performance tools, AppDynamics, New Relic, CompuWare, Ruxit, all these sort of tools aim to provide this visibility so that when you're running load tests, you can see what actually breaks, understand where your requests are coming from, and what performance looks like inside of the browser. And you can do so for each endpoint. But oftentimes, it's not just enough to understand how to write the code. It's not worth it to write the code when you can just use a service, depending on how much engineering capacity you have. So I like to mention some load testing services that are available. So Apica is probably the most complete load test service I'm aware of, that has servers all around the world. It can handle mobile interactions, web interactions. There's Blitz.io, which is a great tool for quick and easy load test of a single endpoint. And then BlazeMeter, which is effectively JMeter in the cloud, but they've recently added support for running locustios for many instances around the world. So it's not just enough to test for the success conditions, you really need to start to test for failures as well. So nobody has learned this better than Netflix, who introduced this a suite of tools called the Simian Army. One of those tools is called Chaos Monkey. And what it will do is go into your AWS, Amazon Web Services infrastructure and create chaos. So shut off network ports, kill services, and start to see how your applications respond. So you should run load tests, and you should also understand what happens if things start to break. What happens under production load? So what happens if you lose a caching layer? What happens if your dependencies slow down? Do you retry, exponentially back off and retry, or do you just block and fail on the connections? So these are all things that you should start to take into account when you run load tests, and you should run them both under ideal conditions as well as under real-world conditions where failures do happen. I think you eventually learn that and software eventually will work and hardware will eventually fail, so you should test for both. So follow some best practices. Treat performance as a feature. Capacity plan and load test on the server side. You should optimize and performance test on the client side because understand more latency comes from the client side than the server side. And understand your starting point. You can't understand the change unless you know where you're starting from. So instrument everything that you can and monitor performance, not just in production. Don't let your users notify you when things are broken. You should find out before that. Preferably, you should find out when you introduce a bug, when you actually commit the code. That's the whole reason you write unit and functional tests, integration tests. So treat performance the same way and write performance tests as well. Measure the difference of every change. It's not just the database or upgrading your version of Python or the version of Django that you're running. Everything affects performance. So automate performance testing in your build and deployment process and ultimately understand how failures impact performance because it's an imperfect world. And at some point, things will break. So this is great for the HTTP 1 world, but the reality is that the protocols are evolving to support more. I think there's a talk on HTTP 2 earlier today by Davey. So some of the limitations in the HTTP1 world have been fixed in HTTP2. HTTP2 eliminates the needs for things like concatenation and sharding and all these other hacks that we had to build around for HTTP1. So a lot of those things, a lot of the best practices today are anti-patterns for tomorrow. So understand that when you're trying to move from HTTP1 to HTTP2, what the impact of those optimizations are. There's a great book by Ilya Grigorik, who's developer evangelist at Google. You can get it for free at hpbn.co/http2. Now, most of the libraries I talked about don't support HTTP2 yet, but they're working on it. In the between time, there's the HTTP2 h2 load command. So you can use ng-http2, which is a C library for supporting HTTP2, and they have a built-in test client. So if you want to start load testing this as well, you can do the same thing. You can just run h2 load -c for concurrency -n total number of requests. So the idea here is to support as much as possible with a wide array of tools. So we talked about Apache Bench, we talked about bees with Siege, bees with machine guns, locustios, SitesPIO, web page test, and now h2 load. That should give you a pretty good place to start bootstrapping all of your load tests from. So again, just to recap, integrate automated performance testing into the continuous integration side, on both for the server side and the client side. Understand the performance implications of every deployment and package upgrade, and monitor the end user experience from end to end in production. And I went a little bit faster than I anticipated. I didn't think I'd get through that many slides that quick, so we'll open it up for questions. So you can find these slides on speakerdeck.com. So speakerdeck.com/Dustin Whittle. They're all posted. In the notes of all of these slides, they have examples for all of these tutorials. If you want to get started running distributed load tests, the best thing that I can recommend is to follow the tutorial from Google, somewhere in here, on running distributed load tests with locustios. This basically will show you how to use Google's cloud, spin up locustios, run parallel load tests at massive levels of concurrency. And then if you just need to pick one front-end tool, I would recommend SitesPIO. All right, any questions? Let's not all ask at once.
What is the best browser in terms of client-side performance?
Not starting that war. So I prefer Chrome. If you actually look at the benchmarks, Opera does pretty well depending on the conditions. But I think general purpose browser, Chrome is probably offers the best performance. It's all the V8 engine underneath. Chrome and Safari share the same engine, although recently they forked. Yeah. Bees with machine guns is really AWS specific. With locustios, you can very easily automate spinning up new instances. Yeah, so you can support any cloud platform. The reality is all these tools, all they do is turn on an instance, install the client library, and then run parallel SSH sessions to run the commands concurrently, and then gather the results. You can automate most of that pretty easily. Yeah. This is a lot of what I use Gulp for, Gulp and like the various APIs underneath. So Bodo exists for all the AWS services. Google Cloud has one. OpenStack has one. So they're all relatively the same underneath, which is I want to generate a compute instance of some kind. Anything else? So it depends on every application. One of the nice things that yeah, so how do you set the baseline for test? Is this something that should be static, just like a minimum latency per request per second or a maximum latency number? Every application is different, so oftentimes you don't want to use a static threshold because your homepage is cached and is very fast, whereas the checkout process talks to a payment processor, shipping service, anti-fraud service, et cetera. So you can't just assume that the numbers should be static. I actually like to look at the average latency over time. So most of these tools can report the latency to something like StatsD, and then you can graph it out in Graphite to understand what your average is for each different transaction. Varnish has a replay log. There's a bunch of different ways where you can look at what does the normal response time look like. If you use something like Google Analytics, you can turn on the site speed feature in Google Analytics. It will track performance of your end users, and then you can understand for each transaction what normal performance looks like. If you use some of the commercial performance tools like AppDynamics or New Relic or Ruxit, a lot of what those people will provide are a baseline of performance, and you can use that as your standard. Usually I work for AppDynamics, so usually what I use is our dynamic baseline, which will tell me, you know, historically looking back 1 month, what's the average latency for this specific transaction. And then I use that. That's variable. That depends on, you know, production's going to be different than development because the load and the data storage is going to be different. So there's no great answer to this. I would say look at historically what the normal mean value is. Anything else?
Hi. Was there an HTTP2 version of Locust or some comparable load testing tool for complex user behavior?
Not that I've found. You can easily extend locustios to use another library, and you can. There's Hyper, I believe, in Python, which is a HTTP2 client library in Python, and you can use Hyper combined with Locust 2 to be able to do HTTP2 testing using locustios. Basically, you can use locustios to test any sort of service. It's pretty extensible underneath. So you just need to extend it a little bit and use a different HTTP client library to actually make the request. But all of the metrics gathering will be the same, and same with the UI. Yeah.
Okay, thank you.
Is there like a big elephant in the room where you would say this is the one thing that usually causes most performance issues?
Yeah, blocking on the front end. Some common best practices for building server-side applications are leverage caching, use Redis memcache, use view caching, use caching at the database level. Queuing, you do stuff in the background, don't block on the front end. I've done a lot of consulting on performance, and what I find is everybody blocks the front end connection to do things that take a really long time. And oftentimes what you should be doing is putting this in the background, have workers work on it, and return the response as fast as possible. You should only ever block the requests unless it's needed for the immediate next interaction. And most times people just do this all in one gigantic action or controller. So this is what I see as most common. That and people don't use basic caching. There's the Nginx server boilerplate and Apache server boilerplate, which will give you Nginx and Apache configurations that have best practices built in. So to use caching for CSS, JavaScript, HTML, etc. And most people don't even do that basic step. Yeah, I would say that's probably the biggest things. Anything else? All right, well, thank you very much for your time. My apologies it was so fast. You can find the slides at speakerdeck.com/Dustin Whittle. I'll be around for the next day or two, so if I can be of any help, please just let me know. Cheers.